Thursday in class, we looked at how you can really transform a function algebraically as compared to just on a graph. And we started by just reviewing that we're right now working with our quadratic functions in vertex form, which is the form a times x minus h squared plus k. A really tells you about whether there is a x-axis reflection and or whether there was a vertical stretch or shrink. Okay? The x minus h lets us know if there was a horizontal translation. This is your left and right motion. So x minus h goes to the right, x plus h goes to the left. And then k causes a vertical translation, moving up or down. Now, if you are starting with the parent function, which is y equals x squared or f of x equals x squared, you can immediately write something in vertex form based on the changes they describe. For example, if you look at this problem here, it says let the graph of g be a vertical stretch by a factor of 2. Okay, well that's going to involve a, and a reflection over the x-axis. That's also going to be something we need to look at for a. Followed by a translation of 3 units down. Okay, well that involves k. And it says, of the graph of the function, f of x equals x squared. That is your parent function. So if you start with the parent function, you can immediately write something that is in this form. It says, write a rule for g and identify the vertex. Well, what we just listed out is that a reflection over the x-axis, that causes our a value to be negative. A vertical stretch of 2 means that our a value is actually a 2. And so what I can do is in my new function, I know that my a value is going to be a negative 2. Now, the next part of the vertex form is did the graph move left or right? Well, nowhere in here did they talk about a left or right translation. So it's not moving at all. It would be like h was equal to 0. And so you can write x minus 0 squared if you would like. We'll come back and simplify that in a minute though. And then it talked about translating 3 units down. Well, that lets you know that we're actually going to subtract 3 or put in minus 3 for k. This is basically your function for g. However, we don't need to write x minus 0 squared. We can just write that as just x squared. And so this would be your final transformed function. The problem is that you don't always start with the parent function. And if you don't start with the parent function, you really need to think about the transformations that we talked about and that we have on our cheat sheet from the last chapter. That's actually still really helpful. So I would suggest as you go through some of the homework problems that you have that out. So if you look at this next example, it says let the graph of g be a translation 3 units right and 2 units up, followed by a reflection over the y-axis of the graph f of x equals x squared minus 5x. Well, that right there, that is not the parent function. So we're going to have a little bit of a different plan, okay? So let's just list out what we need to do. We need to move it 3 to the right, we need to move it 2 up, and we need to reflect it over the y-axis, okay? So let's kind of go through in the order that they've listed. It says let it be a translation of this and this. So let's start right there with those 2 translations. According to your cheat sheet, to move or to transform a graph to the right, that is actually going to be x minus h, or in our case, x minus 3. So according to your cheat sheet, what that means you need to do is you need to go through your function, and anywhere you see an x, you are going to replace it with x minus 3. All right, so my new function is going to start like this. I have x squared, but to move that to the right, I'm going to replace the x with x minus 3. So it looks like this. And then minus 5 times, but instead of writing x, I'm going to write x minus 3. Okay? So that right there, changing your x's to x minus 3, will cause the whole graph to shift to the right 3 units. So we've taken care of that one. Okay, now up to, that's just your k value. That can be accomplished by just adding 2 to the end of our function. Right? And so we've now taken care of that. But before we go any farther, let's clean this up a little bit, okay? Notice that this function, even though it's not the parent function, it also wasn't written in vertex form, which means you actually need to do some multiplying here. We're going to get rid of these parentheses. The one thing we practiced in class is that x minus 3 squared, what that means is it means you have x minus 3 times x minus 3. And so we are actually going to have to do You can call it the FOIL method if you want, but really what it is it's the distributive method. We're going to distribute twice, okay? You're going to do x times x and x times -3. Okay? Then you're going to take the -3 and distribute as well. -3 times x and -3 times 3. And those are the terms that you get when you multiply x minus 3 times x minus 3. Okay? Now moving on, we can also distribute the -5 through this one, and we will end up with minus 5x and plus 15. And then we've got the plus 2 at the end. And when I go through and combine like terms, that will be my function after taking care of the first two items listed. And so when I combine like terms, I will end up with x squared. I've got minus 11x and plus 26. All right. This is the function after taking care of those first two things. The last thing I need to take care of is the y-axis reflection, and this is when you make all of your x's into negative x's. All right, so anywhere I see an x, I am going to replace that with negative x, and then I'm going to simplify one more time. When I simplify this, negative x squared means negative x times negative x, which will actually go to positive x squared. Negative 11 times negative x will actually be positive 11x, and then the 26 didn't have an x, so it will not change. This is your final answer for this example. The assignment is also located on Blackboard, and there's a screenshot of the problems you need out of the book as well.